Hello, today we're going to be talking about lesson 4.3, which is on congruent triangles. Now, we can talk about triangles, but we can also talk about congruent polygons. Any two polygons are congruent if and only if their corresponding parts are congruent, meaning it goes both ways. If and only if means it goes both ways. So, if you have two polygons that are congruent, then all their parts are congruent. If you have something that all their parts are congruent, that means that they are congruent polygons. So for example, we'd know that angle A right here and angle H, since I got the two tick marks, are corresponding. Angle B is congruent to angle J, and then angle C with the three tick marks is congruent to angle K with the three tick marks. Same thing, AB is congruent to HJ. You'll see it goes from red to blue, red to blue. BC is congruent to JK. Again, blue to green, blue to green. And then AC is congruent to HK. And they have to be labeled that way because you'll see right here that A has to correspond with H, B has to correspond with J, and C has to correspond with K. They have to correspond with each other. They have to line up. Same with right here. You'll see an example, okay? You'll see right here, this is not a valid example. A corresponds with H, that's good, but B should be the second position, not the third. And so this is not a valid statement. It does not mean that they are congruent. So let's look at an example right here. Example 1 says, identify the corresponding congruent parts. Show that the polygons are congruent by identifying all the congruent corresponding parts. Then write a congruence statement. So first let's look at angle P. Right here, angle P. Angle P is congruent to which angle on the other one? That would be angle G. It's congruent to angle G. Okay? Angle Q is congruent to angle F. Angle R is congruent to angle E. And then angle S is congruent to angle D. Okay? We also see that PQ is congruent to GF. We see that PS is congruent to GD. We see that SR is congruent to DE. And finally, we see that QR is congruent to FE. So since all of those are corresponding, we can say that PQRS is congruent to GFED. If you'd like to look at some more examples, you can pause the video now and try problems 1A and 1B. Now, example 2, corresponding parts of a triangle. So, in the diagram, ABC, so AB, BC, and AC is congruent to DF, FE, and DE. Okay, so they're congruent. So, it says find the values of x and y. So if we know that this angle right here, angle B, is congruent to angle F, which we see B is congruent to F, if we know they're congruent, that means that they're equal to each other. So I can write 99 is equal to 8y minus 5. Now it becomes an algebra problem. I add 5 to both sides and I get 104 is equal to 8y. Now if I want to figure out the value of y, divide by 8, and I would get 13. Y is equal to 13. Okay? The next thing I can see is that FE, the blue side, is going to be equal to 38.4. So I can write it as 2y plus x is equal to 38.4. Well, we already know the value of y, which is 13. So I'd say 2 times 13 plus x is equal to 38.4. 2 times 13 is 26 plus x is equal to 38.4. Subtract 26, and I find that x is equal to 12.4. There are my two answers. Next thing we can talk about is proving that triangles are congruent. Third angle theorem. It says this: if two angles of one triangle are congruent to two angles of a second triangle, then the third angle of the triangles are congruent. So it says right here, okay, we have angle C is congruent to angle K. We have angle B is congruent to angle J. So if you think about it, since we have the triangle sum theorem, it says that all angles in a triangle add up to 180. If this one is equal to this one, and this one is equal to this one, then obviously the third one is going to have to be congruent to each other. So that would say that angle A is congruent to angle L. So let's look at this example right here. The planners of the senior banquet decide to fold the dinner napkins using a triangle pocket fold so they can place a small gift in the pocket. There's my example right there over in the picture. If angle NPQ is congruent to angle RST, and the measure of angle NPQ is 40, find the measure of SRT. So it says right here, if this angle right here is congruent to this angle right here, okay? See the little tick marks means that they're equal. And we know that this amount right here is 40 degrees, okay? We want to find this one right here, okay? So how do we do that? Well, I can see right here that NQT is a right angle. And I can see that QTR is a right angle as well. So those two are equal to each other. We also know that NPQ is 40, and we know it's congruent, so that means that it's going to also be 40 degrees for RST. Okay, those are both 40 degrees. So if we're trying to figure out this side right here, okay, if I'm trying to figure out this side right here, I'd look and I'd say, if I draw my triangle right here, this is 90 degrees, this is 40 degrees, we can find the value of this x right here. How do we do that? Well, remember in a triangle, it has to add up to 180 degrees. So x plus right angle is 90, other angle is 40, has to equal 180. Okay, so that means that x plus 130 is going to equal 180. Subtract 130 from both sides, and you get x equals 50. So this angle right here, angle QNP, is going to be 50. And by the third angle theorem, that angle SRT is going to have to also be 50. So my answer is 50 degrees. Example 4, proving that two triangles are congruent. Now for this one, we are going to have to write a proof. So given that DE is congruent to GE and DF is congruent to GF, and that angle D is congruent to angle G. So we got all these tick marks that let us know what's congruent to what. It also says that DFE is congruent to GFE, right there. Okay? So let's look at our proof right here. Okay? First, we know that DE is congruent to GE, and that DF is congruent to GF. That's given information. Now, if we look at the picture, we can obviously say that EF is congruent to EF. Why is it? Well, the reflective property would say that those would be equal to each other. We also know that angle D is congruent to angle G. That's given information. And that angle DFE is congruent to angle GFE. Again, given information. So that would mean, obviously, that angle DEF right here would have to be congruent to angle GEF. Why? Well, the third angle theorem would say that if two angles are the same, or two angles are congruent to two angles in another triangle, the third one's going to have to be. So then finally, if all three sides are congruent, if all three angles are congruent, then by the definition of congruent polygons, the triangles are going to be congruent. Theorem 4.4, the last thing we're going to look at. It says properties of triangle congruence. So first off, if you have a triangle ABC, it's obviously going to be congruent to itself, ABC. That's the reflexive property of triangle congruence. Just like there was a reflexive property of angle congruence, there's the same with triangles. The symmetric property of triangle congruence. If ABC is congruent to EFG, and EFG must be congruent to ABC. Symmetric. Doesn't matter which way you're going, it's the same thing. Finally, the transitive property. If ABC is congruent to EFG, and EFG is congruent to JKL, then obviously ABC is going to be congruent to JKL. Same thing, just like we've talked about before, this transitive property also works for triangles.